for the test. But yeah, just like on the quiz, I'm going to ask you to explain. And the reason I do this is because there was a problem on the quiz about DMV lines, and I was accepting either ordinal or interval, because you can argue your point either way. Nominal was too much of a stretch, because at least it's ordinal. Why do they give us freaking numbers? So they keep us in order, right? Now, I know they do it like you get B or G or whatever, depending on what weirdness you got coming with, right? But it still is order. But you could argue that you could subtract the number part of that and see how far away you are until you get to this. So I accepted interval. So it depended on the way you argued your point. So that's why I like to tell you, explain your answer, because then maybe you can explain them like, I didn't even think about that. Because some of them, it depends on how you looked at it. Yeah. But this one is definitely, the first one's got to be nominal. Some of hair color. The next one is talking about temperature scale. We know it's interval. What about the last one? The average number of TVs is 3.7. Yeah, because you could have twice as many TVs. You got 4 is 2, it's twice as many. 0 means no TV, right? Would that be discrete or continuous?
Discrete.
Yeah, just because I say 3.7 doesn't make it continuous, right? Or if I said the TV weighed 10 pounds, does that make it discrete because the number I said was a whole number? No, I said a whole number because I'm human, but it probably weighs 9.847629342221117 pounds, something crazy. So that happened in the homework. A few people focus too much on the fact that they gave you a whole number. You got to think, what could it be? Don't look at the number they give you. Think, what numbers could this have? Right?
Wait, so it wasn't not continuous.
If I asked you 4C, if I said, is 4C discrete or continuous, it is completely discrete. I'm now asking you, is 3.7, no, that doesn't make any sense. Is the variable, the number of TVs, is that discrete or continuous? It's discrete. You can't have 1.7 TVs. You're like, well, 70% of the time I have the TV, and the rest of the time she gets the TV. It was part of the deal. No, it's not. It's a nice big TV. They had to. Sure. It's still a TV, right? All right, maybe. I like it.
So technically, can you ask the same question for B?
Yeah, totally. Temperature is a true measurement. So would it be discrete or continuous? Continuous, because I can measure it more and more precisely. But I can never measure the number of TVs more. There's 3 TVs in the house. Can you be more exact? 3.0? Whoa. No, you can't be more precise. It's discrete. 1, 2, 3. Okay, I like it. Oh, there. I was trying to figure out where was my discrete continuous question. It was number 9.
Number 9.
Yeah. So number 9, I was a little nicer to you. I didn't give you a number because you guys focused too much on the number. I just gave you a situation, so that should have been easier to answer. All right. So it's wide open again. You guys can ask questions from quizzes, practice tests, homework, general questions. Yeah.
The homework, section 2.7. Basically it's 94, but a lot of the questions is just basically standard deviation questions. And
94?
yeah.
Okay. Oh, on this one, the standard deviation came in and further down questions.
Yeah, further down.
Yeah.
So,
But 94 we talked about the other day, right? That was a little weird because they gave us 11 years. But 1,014 was the median, so there should be 50% on either side. So it'd be half of 11. So if I know that the median is 1,014, so the median FTES at schools is 1,014, and I pick 11 schools. Can you spell, Jim? How many schools would have, what was the question exactly? 1,014 or above would be, how many, what percentage have above 1,014 if this is the median? 50%. Yeah, so 5.5, right? That's a weird, you can't have 5.5 schools. But again, this is an average. Every time you pick 11, on average, 5.5 of them will have above 1,014. So that's the thing. Some of you guys confused. Some of the questions talk about how much data is here and how much is there. I don't know how much. All I know is, I don't know the numbers, but I know 50% is up there, 50% is down there. I don't know how many that is. So there are a couple homework questions that's the answer. I don't know how many, I just know the percentage. So like that one question that said, could there be more data values above 2 for this one or that one? Well, the whole point of that was, I don't know which one has more in the first place. All I know is the percentages from the box plots. So it all depends on which one has more. So for example, if I had, let's see, this one tells me that's 1,014. First quartile is 528.5. That's Q1, Q2, and Q3 was 1447.5. Right? You guys with me? Okay. And then say this other place has exactly the same numbers. Let's say Q2, Q3, 14, Jeff, let's keep this. They have exactly the same. So say, are there the same number of schools here as there are here? Well, I don't know, because I don't know if there's 500 or if there's 2 schools here. I don't know. I have to know the number of schools to know. All I know here is that what percentage is in here? 25%, right? From the third quartile to the highest, there's 25% of the data. So how many schools are in there? I don't know. If you told me there were 100 schools, then there'd be 25 of them in there, right? That's the point. Box plots only show me percentages. Percentages don't mean shit without the total number. Okay, maybe. Maybe not. All right. Okay. So when they bring the standard deviation in, like number 99 is the only place that, like number 96, you just got to write the number they gave you. Number 96 shouldn't even be there. But 99 says how many standard deviations away from the mean is the median. So the median is 1,014, and the mean is 1,000, and the standard deviations are 474. So how many standard deviations is it from the mean to the median?
Way less than 1.
Say again?
Way less than 1.
Yeah, way less than 1. One step away from the mean would be 1474, right? Do you see that? One standard deviation above the mean would be, and that's only, how far up is it? 14. So I'm just using this formula, except now, let me see if you guys get this. Well, let's just use this. So that, the mean, so this isn't just a sample mean, it's a real mean. So the mean would go here, standard deviation would go there, and I know this is the median, but that's the data point that I'm curious about. So that data value goes here. Right? Or you just say, well, how far apart are these? 14, and how big is the step? So what part of a step is that? You do that division. So you should get really small numbers. Those are really close, right? But the only reason these are really close is because I know what close is for this problem. What if I had 1,014 was the data point, and the mean was 1,000, and the standard deviation is 1.2? Are these close?
No.
Hell no. These are really stupid far apart, right? If on the average the data points are 1.2 away, and this is 14 away, that is way far apart. You guys understand? So there's no absolute distance here. It's all, the standard deviation is relative distance. So these are really close because normally the data points are really far apart. On average, they're like almost 500 away from the middle. That only got 14 away from the middle. It's not very far. Here, on average, they're 1.2 away from the middle. That's 14. Holy shit. That's really far. That is an extreme outlier in that case. Maybe.
And then for 97, it says what were basically the,
Yeah, from 528 to 1447. Right? 0.5.
yeah, and it's just.
If this is Q1, what's Q1 mean? What percentage is below Q1 by definition? Yeah, because Q1 is the first quarter. So that's 25% below. And what's below Q3 the same way? The third quarter. So first quarter, second quarter, third quarter. So what percentage total? Now 75. Exactly. So what percentage is between them? 50. Bam. And that would be the middle box, of course, right? And the box plot, if you made an actual box plot out of this, that middle box, or the only box, would be 50%. Okay. I love it. You guys are like looking like, just tell me how to do this. Yes?
Could you go over number 5? It says, would you use the median instead of the mean to recapitulate?
Oh, yeah. All right. So, that kind of question I wouldn't necessarily ask on the test because I gave you two, and you could use those two. I couldn't complain about it. I gave you two already. When we first started talking about the median and the mean and why do both exist. When do you want to use the median? So what's the general? So on the answer key, I try to put the general idea. In general, you want to use the median instead of the mean when what's true about your data values. When you have some outliers, when you have some extreme values. What's going to be affected by extreme values? The mean will. The median won't give a shit. The median doesn't care what the number is. It just cares where it is, right? And when it's put in order. So the median of these data points, what's the median? 2. What's the median of these data points? 2. Yeah. Right? So the median, I don't care. But what's the mean? The mean changes a lot.
So in like the price of houses, you would use
Beautiful.
the median, right?
So price of houses, because we're talking about La Jolla. I don't pick on La Jolla. I think I'm more jealous of La Jolla. But La Jolla is the place to go to when you talk about house prices and how extreme values happen. What else? So there was another situation with somebody who was going somewhere to get a job. Yeah, and we're like, what would be more honest to tell them, the mean or the median? The median would be more honest, because the mean would include the CEO, which normally would be, especially nowadays. We won't bring politics in. Huh? We won't do that. That'll become a whole different class. We're all about the data. All right? It's totally up to you guys how much we do today or not. Yes?
Can you explain cumulative relative frequency?
Yes. So, think about this for a second. Rain is kind of key for us, right? If I said, how much did it rain yesterday, and you said, trace, or let's say, how much did it rain the last month, and you say, 1.5 inches or whatever, right? I say, what's the cumulative rainfall for the season? You're going to add up all the rainfall each day, right? So if I had a relative frequency list, here's my classes, blah, 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 and I have 5%, 11%, 2%. Then the cumulative relative frequency, the kerf, would be 5% so far, and now how much so far? 16% so far, 18% so far, and of course you better end up close to 100% at the end. What? So just add up the running total. Exactly. Thank you. I'm trying to think of the phrase that would go along with that. Running total is perfect. Yes.
Okay, so like on the homework, I added them all up, but like my rounding was like this a little bit off, and it came off like 99.8. Is that like
That's beautiful. I mean, that's awesome. If you get 103 or 90, like within 2% is better than outside of 2%. If you're outside of 2% away, if you're 2.5% or something in either direction, you've done something wrong. Yeah, something wrong has happened. Some buzzing around? Yes.
Sorry.
Sorry for what?
In might be redundant. If there is there a better way to identify stratified versus clustered random? I get the convenience and I get the systematic.
Gotcha. So stratified, remember the phrase, because it starts with the letter S, remember the phrase sum from all. Stratified starts with S, so it's sum from all. Cluster is the other way around, all from some. So what do I mean? Sum from all, meaning if I broke things up into 4 groups, I'm going to take sum from all of them, right? That's stratified. Cluster is all from some, because it doesn't start with an S. Oh, right, what the hell can I do? So if it broke it up into 4 groups, it would pick maybe 2 of them randomly and take everybody from those and screw them. Why are they both still random sampling though? They both are random sampling. What's the fundamental property of random sampling? Everyone in the population has a chance to be in the sample. Beautiful. And both of these allows for that. You can't say, well, these guys weren't picked because you're looking at it after the sample's been picked. And then nothing in the damn universe is random. Well, they didn't pick me. No. Did you have a chance to be picked? Yeah, everybody had a chance to be picked. I randomly selected those 2. It could have been those 2. I mean, everybody had a chance. Therefore, it is truly random sampling. Both of them. They're just more specific. So you have to be as specific as you can be when asked this. They'll just say random for everything. Yes?
So you know if you say like everybody has a chance, it's gonna be.
Well, it's random. So I'm just talking, these are 2 specific sampling types that also would end up being random.
So when would you go random?
If I said I put all the names in the hat and had different people pick names, that's not strata. I didn't break people up into groups at all. So it's neither one of those. It's not convenience because I put everybody's name in there. It's not convenient for me, right? I had to write them all down. It took time in my imagination. But it's random. That would be purely random when there's no system, when there's no organization to it at all, but everybody had a chance. That's random. Man, you guys really don't know what to make of today, do you? You're staring at me like I'm crazy. This all depends. If you haven't done much homework, I understand why you don't have any questions. But if you have, you should have questions. Yes?
Can you do number 6?
I gave examples. Let's see. Right, make sure you have 2 sides to this, by the way, to your answer key. I forgot to say that. My printer likes to mess with me. You have 2 sides to your answer key. Make sure. Otherwise, you don't have all the answers. That sucks. The mean. So, is it true or false that the mean and the mode can never be the same?
False.
It's false. Now, why did I do median then? I did mean and median. All right, maybe I changed it. So, how can I do? Hey, there's something else I changed. What would be an example that shows the mean and the mode are the same?
Symmetrical.
Give me a very, very specific example.
1,
2,
4, 4, 4, 4.
Well, the mean and the mode. 1, 2, 2, 3. How's that? What's the mean? 2. What's the mode?
2.
There you go. Sweet. So I think I must have. I was really evil myself. I think I changed median to mode at some point. And then now the answer key is not quite right. So number 6A. I had median here. I think some earlier version had a median up there. But this is the mode. This is an example to show that the mode can be the same as the median. So I could very easily put true or false questions on the test. Examples are a really good way to show me stuff.
I'm not going to need to write something. I'm just.
You can show me a specific example. Yeah.
Yeah.
Exactly. You don't have to explain in general. Well, no. Okay, that would be horrible. You just got to show me an example.
Would a graph be acceptable? Like one of the.
Oh, yeah. I mean, what's true about normal curve, the mean is the same as the median, is the same as the mode. So you could just draw a normal curve and say, there. Just indicate, when you draw a normal curve, you say that's the mean and the median and the mode. Bam! Because it's the tallest point It's in the middle symmetrically, and it's the average, right? Yes?
I have a question. For number 1 on the practice test, you put you wanted the medium. And where did you get 16 from? Isn't it 15? It was 15.
Where are we at? Sorry.
Number 1B.
Oh, all right. So there's a formula for the median. I think somebody's asked me about this earlier. You do n plus 1 divided by 2. So watch. What's the median for 5 numbers? It would have to be the third number, right? 5 plus 1 is 6 divided by 2 is 3. There. So that's, I think I do reference that in the book.
Divided by the average.
Yeah, I just always forget to say that, but yeah, that's what I was doing. I did 15 plus 1, and then divided by 2, and that's where the answer is, and then you go get the answer. Cool.
And would that change if there was a population in the sample, or is that a different formula?
Oh, no, it's the same. If it was population or sample, it's the same.
Okay.
Yeah. Standard deviation is the only one that's freaky. Yeah. The mean formula is the same. The median formula is the same. Percentiles are the same. Standard deviation just goes a little freaky. And does it make sense? Standard deviation freaks out because it's built on the mean, and the mean would be different, very possibly. So that's why there's an adjustment for the standard deviation. It's based on something else. Yes, sir.
For 8B, in this case, would the 14% be the sample of the...
Oh, good. I love it. Okay. I put this on here for a very specific reason. This drives me a little crazy. Your sample has to be the people or things you looked at or talked to find something out. So how could I, if my sample were the 14%, how did I psychically know to pick them? The ones that liked parking, I just went, you look angry, but I know you like parking. Yeah. Does that make sense? I mean, who did I talk to on 8B?
180 students.
That must have been my sample then. What's the 14% got to do with the question? Not a damn thing. But what is the 14%?
The amount of students.
It's a statistic. I loved it. It's how I analyzed my sample. So it is not the sample. I like it.
The sample's only 3, and then the population would be gross amount.
No, the beautiful thing is, so the sample would be 183 students of Grossmont,
Okay.
and the population changed the number to the word all. That's insane. So if you can figure out the sample, you automatically know the population. You picked the sample from the population, so the sample has to be a group out of the population. So they should be almost the same wording, right? That's my hope. So like 8A, 322 telephones taken from a phone factory, what's the population? Population.
All telephones.
All telephones at the phone factory, and the sample would be 322 phones at the phone factory. Bam! So you just change the word all to the number that's picked, right? Yes, sir.
Okay, I have a question on quiz 1.
Yeah.
Okay, so my question was the one about researchers in Sweden and the wine drinkers. Okay, so would the population be all the wine drinkers?
What was your sample?
I think I got completely wrong.
But look at it again. What do you think the sample is? Who did I talk to? Or who did I experiment on?
Wine drinkers.
No. Read it more carefully. What were the 3 groups?
Okay, heavy wine drinkers, light wine drinkers, and people who don't drink.
There you go. So your population couldn't possibly be wine drinkers, because then how did I get that group of people that don't drink wine? So the population is everybody in fill in the blank. So some of you guys had Canada, some of you guys had Brazil, some of you guys were talking about wine, and some of you guys were talking about infections in hospitals. Too bad for you.
Everyone is.
Some of you guys got wine, and some of you guys got infections. That sounds like normal weekend. What's that?
Everyone in Sweden in general.
You just say the population is everybody in Sweden. Because you could argue, you could say everybody in Sweden who can drink, but for one thing, their ages are different, right? But even then, if I had somebody who's too young to drink in some country, I still want to look at them because they would be a control group, a control person against somebody who has been drinking, wouldn't they? So I want them in my sample. So in that case, my population is everybody. Everybody could have been picked.
Yeah.
And then your sample would be, you could be very specific. You could just say the blank heavy wine drinkers, the blank light wine drinkers, and the blank, and that's my sample. That's who I actually talked to or did stuff to, poked them with stuff. Took the blood, whatever I did, yes.
For the, you wanted to, I'm back on one again, sorry. For number E, you want the range of variance in the standard deviation. How do you input in the second one for your action laser? You get, X minus, or you line 1 minus.
Okay. So you're going to put all the data values in L1.
Yeah,
Yeah. You got to get the mean next.
and I have that.
And then L2 would be L1 minus the mean. And then L3 will be that squared. So I get X minus the mean squared. Cool.
So you went over cluster, stratified, random, and then for convenience, it's whatever was available.
Yeah, if I said I stood outside the parking lot and talked to people as they drove off what they thought about gas prices. Okay. That's convenience because did everybody in the population, who do you think I'm trying to talk about? I'm probably not trying to talk about the people who happened to be in the parking lot at the time. I'm probably trying to talk about people at least in San Diego or something, or El Cajon or whatever, right? So automatically I'm not targeting my population. I mean, did everybody have a chance? No, they had to be in the parking lot, so they had to have a reason to be at Grossmont at this time. So convenience, it's convenient because I didn't have to try to be representative at all. I didn't try to do it. I'm just saying, let me just talk to people as they come by. Now, if you had a list and you took every fifth person off the list and you went to talk to them, that's systematic. It's not just convenient because you have a list of everybody. So somehow you've taken into account everybody, and everybody has a chance. But even if I was sitting outside the parking lot and I talked to every fifth person who left the lot, it's still freaking convenience. Because did I try to make sure that everybody that I'm trying to talk about was included? No, I'm not. I'm just taking people as they leave. I'm like, I got some time. Let me just sit here and talk. I didn't put any preparation into it ahead of time.
Could you argue that it's systematic since you have a system of taking every fifth card?
No, no. I'm systematically being convenient. So
Like, what would be a prime example of systematic? I know you said.
So like I said, if I had a list of all Grossmont students, and I randomly started somewhere, and then I took every fifth student. So why is that not just convenient? Well, because I've got everybody. Everybody has a chance to be in there,
Okay.
right? I like it. Okay, maybe. Yes.
Okay, so another question on the quiz. So it's the same question on the practice test as well. It says 30% of them were blonde. That's nominal, right?
Yeah, totally. In fact, on the quiz, I was trying to be a little nicer because I understand the people that say, well, maybe it's the question was how many were blonde, but I try to make it really clear. And I said 30% blonde and then comma something else. Yeah, so it's really obvious then that what must I have been asking people, or looking at least, what was the question I had in my mind was what is your hair color, right?
Yeah.
So that's nominal. The number is what I did with the data. It's not the data, it's what I did with the data. And I know it seems like I was being mean, but no. You just got to know the difference between what's the analysis I did and what's the actual data that I was working on.
The type of sampling method on my search, would it be stratified? I put random because, like, I don't know, it kind of threw me off with, like, the randomly selected. If you want heavy.
So remember, a big key part of stratified and cluster is once you break them into groups, you randomly select. That's a part of it.
Yeah.
That's what makes sure that it's a method that I want to use. But it's not just random because there's more organization to it than just throwing things in a hat.
Okay.
So it's a higher level. So random's sort of like a lower level.
So, like, a better way I can think of it is, so stratified is, like, you said sum from all.
Yep.
And cluster is
All from some. So if you break them into groups, like I break I break California up into 112, or now it's 113 community colleges, and I take every student from 60 randomly selected colleges. What would that be? Cluster, because I took all from some. If I took 80 students from every community college, that would be stratified. I always think about stratify like strata. I'm just hitting everybody. I don't know. It doesn't quite go together, but. All right. Some of you look really depressed. I'm sorry. Some of you look okay.
Standard deviation, do you do 3 decimal places?
Yes, standard deviation is the first thing I've been very clear about. At least 3 decimal places. Less than 7 decimal places. Just to stop, I have people sometimes that like take it out to 18. I'm like, holy crap. But if you do more than 3, that's even better. But when you do 2 places, that will throw some key things off later. So I want you used to getting at least 3. And when I say that, I mean if you get a standard deviation of point, I think I've already said this, but if you get 0.002798 is your standard deviation, don't round that to be 0 and say, okay, that's 0.000. You round it until you hit the non-zero number, so it'd be 0.00279. I can remember what I said.
3 sig figs?
Yeah, exactly. If you're in science, then 3 sig figs. Yes. Oh. Yes.
So versus using population standard deviation versus sample standard deviation. Like so we have the variance the U versus the X, so mean versus median, right?
Oh, no. Just sample mean